Yes.
No.
Yes, we are done. I mean, I am done. Sorry, excuse me, teacher. What is the second last word? The second last word after end, before end, sorry. Six, the last one. Is that either or? That either? No, the other one. This one. Is that either or other? Okay, thank you.
Yes, teacher.
No, we haven't.
Yes.
Yes, teacher.
Complete the position where 5 kilogram mass would be placed on the rod so that the rod remains horizontal and the tension in the string is 0.
That part which you see, and then we start on the answering the question. So, we want to start on this question. Okay, I hope we are able to start on this question. Do you see this part of the board? Do you see what I'm writing?
Yes,
You
teacher.
can't?
Yes, we can see.
Okay.
We can see.
I'm starting on this question and I'm picking the major part. I'm talking. That is my role. Is that okay? At the end of this rod, there is a string. That's that string. Now, what is the force that acts in the string? Can you tell me the force acting? It is called tension.
Tension.
Is that okay? So this tension is equal to that. That is the tension. What is the tension that must be in the string?
0.
So tension is equal to 0 newtons. Okay, how long is this rod? What is the length of that rod?
4 meters.
So it starts at 0 and ends at 4, and it is in meters. What is at the 2 centimeter mark?
Center of gravity.
Yeah, it is center of gravity. Yeah, you are right. At the 2 centimeter mark is the center of gravity given by mg. So the force acting there is mg. That is at the 2 centimeter, the 2 meter mark. Okay. So what is this force here? What is the mass? What is the mass?
2 kilograms. 5 kilograms.
Mass, it is 2. It is 2. So 2 multiplied by what?
So we can't sit down.
Shall we can sit down?
Can't see at the bottom of the
Hey.
chalkboard.
Yeah.
Can you see that? Can you see the diagram now? I'm working with that diagram. Yeah.
Yes, teacher.
So I'm looking at the mass, which acts as the center of gravity, and the mass was given as how many kilograms?
2 kilograms.
Mass of the rod. So we multiply that by G. What is G?
10. 10.
10. So how many newtons are working here at the center?
20.
So we have 20 newtons acting on the center. Now somewhere here we have a pivot. Was the position of the pivot given? The position of the pivot. So the position of the pivot is 1 meter. I hope you can see that.
Yes.
So from 0 to 1 meter, this is 0 meters, the end, that extreme end. At that point, we have that. At this point, we have that. At the extreme end, or 4 meters, we have that. So at the pivot, we have, that is our pivot. So this is our pivot P. And remember, all distances can be measured from the pivot. Is that okay? Now, what is the question asking us?
To determine the position where a 5 kilogram mass can be placed for it to remain horizontal, balancing
For the rod
horizontal.
to remain horizontal. Is that okay? So, and they have given us this condition that this tension here must be 0. Okay, so where will we put the position with the 5 kilogram mass? Let me assume that we put the 5 kilogram mass at that position. I don't know where. So this is the 5 kilogram mass, but I multiply 5 kilogram by what?
By 10.
By 10. So that I get
50 newtons.
50. And I don't know this position here. Do I know that position? So what should I call it? I don't know that position. I hope you realize that.
Yes.
Okay. Now let us take moments from that diagram. Suppose moments are acting around the pivot. What is the direction of this force here? Will it be clockwise or anti-clockwise?
Anti-clockwise.
It will act in that direction, isn't it?
Yes.
You see that direction? What about this one? What direction will it be?
Clockwise.
It will be down like that. What about this one? What direction will it be?
Clockwise.
Anti-clockwise.
Upwards or downwards?
Upward.
I think like that, isn't it?
Yeah.
See the diagram? Yeah?
Yes.
Okay, you see the diagram. I hope you see the diagram. Now copy that diagram because it is your understanding. We are looking for this distance. Give me these distances here. Girls, I want you to give me the distances. Yes, please.
So can you put, does the 50 kilogram mass have to be at that point, or you can put it at any point?
It is at any point, but preferably I'll put it that side because I'm looking for that position.
Show which position?
Where it is. I don't know where it should be because that's what they're asking me, determine the position.
So can you put it after the 2 meter mark?
Yes, I can put it this way if I wanted.
Okay, teacher.
It is okay. Actually, you are going to discover that the position will depend on the what I will get will be the sign. The sign is what will determine the position. So let us assume what this distance be. I don't know what that is. Can I call that distance from the pivot? Can you give it a name? You don't know that position.
S, teacher.
P.
S.
Okay, let us call it what X. That distance is okay. We call it Y. It is okay. That is that distance. The distance Y from the pivot. Now, what is this distance from the pivot?
1 meter.
1 meter.
1 meter. So what is this distance from the pivot?
2 meters.
2 meters.
This is before.
3 meters.
This is
3
1.
meters.
This is how many meters?
3 meters.
3 meters. So I hope you have labeled your diagram properly. All distances are measured from the pivot. Are we clear about that?
Yes. Yes.
Okay. If we are clear about that, remember that they told us that the road must remain horizontal. So these are the key points. The road must be balanced, so it must be horizontal, and the condition is that the tension in the string must be 0. So now can we do our working? What can you tell me what to do? We are going on this side. Okay, let us erase this.
Oh. Yeah.
As we are doing, those who are saying, oh, we are giving you a minute. Do you see everything we have written?
Yes.
Because of time, we are going to move on. So can you tell me the anti-clockwise moment? I want to go up here. Remember that the condition is that for this road to be balancing the anti-clockwise moment, and I'll abbreviate that. Anti-clockwise moment must be equal to
Clockwise moment.
Do you see that part?
Yes.
Okay, so can you give me the anti-clockwise moments?
50 times
50
Y.
times Y.
Y
Y, good.
is equal to
Only anti-clockwise
That's the
moment.
first
Plus.
That is there another one?
Yes. 0.
0 times 3.
There is another one
0.
plus tension
0 times 3.
3. Is that okay? And
Is it
this side we have
20 times 2?
20
50 times 1.
20
1.
times 1. That's why we have the distances. Okay, so this is 50. So what we get, 50 times 1 gives us
51.
50Y.
what is our tension?
0.
0.
So this is the same as,
Wait.
so we have, is that clear?
Yes.
What is our Y?
1.4.
Oh, mathematics.
20 divided by 50, not 50 divided by
0.
0.4.
0.4 meters. Is that okay? So
Yes.
where should be the position of that? Remember, 0.4 measured from here out there. So 0.4 meters from where? Let us give the correct answer. It should be, let us assume that we are reading distances from this side. If this is 0.4, what is this?
0.6.
0.6 centimeter mark or meter mark. Is that okay? So the pivot should be placed at okay. There are two possible answers. You can write this answer in very many ways, but we can capture all those as being the same. So let us, I think let's take distance from the pivot, but we must consider the side, okay? So yes, we can conclude that. Which mass are we positioning, by the way?
Can you please tilt your PC?
The 5 kilogram mass
Mass.
is it placed at
0.4
0.4 meters
keyboard.
from
The
the
pivot.
pivot. Somebody could answer it like that. Another person could have another version. It could also be placed 0.60 meters from which point?
The 0 point.
Okay, so 0 point. All these answers are all acceptable.
Teacher, do we have to end it like that or?
Yes,
And
You have to conclude.
because you have to conclude.
Oh, okay.
Okay. On the zero mark.
The word zero.
That is better. Yes, please. You don't see the lower part,
Shall we see?
The upper part.
the upper part.
Yes, now we can.
Turn around the whole thing.
Yeah?
So I have a question.
Yes.
When doing such a question, like let's say this question was given to you. When doing
what?
when doing such a question, you have to draw the diagram or it's not a must.
You have to draw the diagram. That diagram without, because it is the one that gives you the information.
How will you determine that?
The diagram is very
The clockwise and anti-clockwise.
in this topic, diagrams are very crucial. They are a must. Are we clear about that?
Yes.
The diagrams are a must. We should not even, because that's where the information is picked from. Okay. Okay, so that is the, we are going to be slow with the calculations because the calculations are quite many and they give us different information.
Can we move on to the next number?
Yes.
Yeah, how do we
do what?
how do we know that the string like is going upwards? Oh.
Remember, we said imagine if it is the only force that was acting on that road. In which direction would the road move? If that string was the only one acting on that road, where would it take it? Downwards or upwards? Who asked that question? Upwards.
Yes.
And then considering the position of the pivot, when you look at that outward, it is upwards, anti-clockwise.
So suppose you have a string here and there's a pivot here. This string is supporting, I hope you can see me, it is preventing this body from going down, isn't it?
Yes.
So where is it acting? By preventing the roller to go down, where is it acting? Upwards or downwards?
Upwards. Upwards.
It's acting upwards. Do you see how it behaves with relationship to the pivot?
Yes.
So it is acting in that direction.
Okay. Thank you.
Excuse me, teacher.
Yes, please.
I'm confused on why do we say that the 5 kilogram mass is placed at 0.4 meters from the pivot?
From the pivot.
Because that is where Y
Was it, what was the distance of Y?
Do you have a diagram?
Yes, I have.
Where is your Y? Do you see where Y is?
Yes, it's.
And that is what we determined, and we found it to be 0.4. So don't you see that Y is from the 5 kilogram mass to, it is the distance between the 5 kilogram mass and the pivot.
It is the distance between the line of action of the 5 gram mass and the pivot.
Okay, thank you.
Okay. If there's no other question, we move on to the next number.
Okay.
Yeah.
I hope that has been
Yes.
captured.
Teacher, pardon on that one.
Teacher, I'm confused, where does the 0.6 come from?
Yes,
Oh.
teacher.
Somebody was answering you.
It's the distance from the 0 mark to the 5, where you mark the 5 kilogram point.
So we say this was 0. We place the pivot at 1 centimeter.
1 meter.
We have mass at that 2 times G. Then we have the tension there. So we say that if we place this one here, the 5. So we measure this distance from here to there. That is our y. So our y was 0.4. Measured from where?
From the mass to the pivot.
From where?
The mass to the pivot.
What is this distance? If this is 1, if this is 0.4, and this is 1, what is the remaining distance?
0.6.
So it is 0.6 measured from the starting point or the 0 mark.
Yes.
Are we okay now? So we are selecting select which answer makes more sense to you.
Doesn't make sense.
Yeah?
What doesn't make sense?
Are you sure? It doesn't make sense. Isn't that an attitude problem? You must identify your problems clearly, because sometimes it is more of an attitude problem. I've told you, measure distances either from the pivot or the 0 mark, and then you say it doesn't make sense. I don't understand that also. Yeah?
Can we move
Okay.
on?
For us, we are moving on because it seems we're not paying attention.
Teacher, I have a question.
Yes, ask.
I wanted to ask, since you said that we can put our 5 kilogram mass at any point, it means each one of us will have different answers.
You will have different answers which will come to the same answer.
Tell me I got negative.
You will have different answers, but they will eventually come to the same answer if you do your work correctly.
If I got negative 0.4.
Negative 0.4 from where?
When you put it at the right-hand side of the pivot.
That is it. So it is 0.4 because it is on the right-hand side, but it is still, so the negative is telling you that in actual sense it must be on the opposite side because the moments have direction. So the moment you get a negative answer, it means that where you placed your body is not the right position. It must be on the opposite side of the pivot. That's the interpretation.
Excuse me, teacher.
Yes, please.
Teacher, I'm confused on why we don't use both why we don't say 1 times 20 on the right hand side, and we just went for the one of 0 times 4. 0 times 3.
Yeah, what do you get? 20 times 1, what do you get? Isn't it there? It's up there on the first line. 50 times y plus t times 3 plus 20 times 1. Isn't that the one you're looking at?
Actually, I don't understand the question. Maybe because I removed the diagram. Because we showed you how the 20 came about, the 50 came about.
What's your question?
No, I think Layla was trying to ask why you moved from 0 times 3 to 20 times 1. She was wondering why they were placed where they were placed. And I think the answer would be that the ones on the left-hand side are the anti-clockwise movements and the other ones are the clockwise movements.
It would be the other way if she had put the 50.
Leila, are
the
you
50
there?
kilogram
Has
mass
she
on the
answered
other
your
side.
question?
Here.
Has she answered your question?
Yes, she has. Thank you.
Mr. Njebu, she has answered.
Okay, let us get more practice. I think this question will be answered. Let us pick the next question, but please, I hope you have the solution to that.
It is the other side. Can you see that second question? I don't know the number.
No. We can't see it, teacher.
Even now, you can't see it.
Yes.
The camera up.
The two part we see in the diagram.
The figure below shows a uniform meter road. You can't see it.
We can see the meter rule, but not the question.
Yeah. Is that okay now?
Yes, thank you.
Yes.
That was the question. In the previous answer, we were telling you that questions that require position, you put the mass anywhere. If you get a positive answer, that is, you take it the way it is. If you get a negative answer, it means that you take the negative distance, you take the opposite distance of where your pivot was.
Oh, it means it's on the other side.
It is on the other side, opposite side of the pivot, or from where you placed it. That's the meaning of a negative.
So then what do? Do you change and draw that mass on the other side?
Just focus on this side of the pivot, that is all. Because here you are talking about distance from the pivot. So the negative, you ignore it and you only take the magnitude of that answer.
Center.
We have a musician that usually indicates that they have done the copying.
What time is it?
39.
You can write one. Next week.
Excuse me, teacher, now it comes with similarity. How come that some of the not process are set in a condition which I can
I can clearly see the numbers.
Yeah?
The numbers, they're not clear.
The numbers, you don't see the numbers.
Yes, on the meter road.
35, 40, and 10.
Do you see them better now?
From left to
yes,
right.
Thank you.
So we are done.
Okay. Yeah, Mr. Sal is coming to discuss the number.
Good morning, teacher.
Okay. All right, ladies, let's go through the solution of this number. The figure below shows a uniform meter rod balanced at its center by different forces. So every time you read a question, there are some key terms to pick out. The first word is balanced. Okay, the first one is a uniform meter rod. So the first keyword is a uniform meter rod because it implies a lot about the solution you're going to give. Then balanced, that means it is in equilibrium. So the two conditions for a body to be in equilibrium, they stand. What else? And it's at its center by different forces. So when they say balanced at its center, also the word center implies a lot from our previous discussions of the center of gravity of a uniform body. All right, so let's someone quickly remind us, a uniform meter rod, what comes to your mind when you talk about a uniform meter rod?
Its center of gravity is in the middle.
Wonderful. Its center of gravity is in the middle. Okay, all right. And then they say that it is balanced at its center. Therefore, where the pivot is, that's where its center is, okay? Now we are going to determine the clockwise, because to determine the value of T, this T, the tension in the string, we need to use the principle of moments. And that principle of moments has two conditions. One of the conditions says the sum of the clockwise moments at any point is equal to the sum of the anti-clockwise moments about the same point. So that means we need to determine the clockwise moments and the anti-clockwise moments about this point, the pivot, okay? So I'll start with 8. 8 is likely to turn this body in which direction?
Clockwise.
This is a clockwise direction. To give us a clockwise moment. We come to T. T is likely to turn this body in which direction?
Anti-clockwise.
Anti-clockwise. Anti-clockwise. Wonderful. This is anti-clockwise. We come to 4 newtons. It is like to turn the body in which direction?
Anti-clockwise.
Wonderful. You are such a wonderful class. So this one will be in the anti-clockwise turn. Okay. So after identifying them, we need the perpendicular distances of these forces from the line of action of the forces to the turning point. This one is very clear. The one for 8 newtons. Who can tell us that perpendicular distance?
40 centimeters.
Wonderful. Then the one for 4 newtons from the line of action of the 4 Newton force to the turning point is also very clear. Who can tell us that distance?
35 centimeters.
Wonderful. Then we come to the last force. We have T. What is the perpendicular distance of this force T from the line of action to the turning point?
50 centimeters.
50
centimeters.
Wonderful. So this is 50. Now, after identifying that, then you can go and apply the condition, okay? I believe we can see this part of the board.
Yes.
Okay, so we shall say that sum, this statement can award you a mark on a good day. Sum of clockwise, we can start this. The unknown is anti-clockwise, so we'll start with the anti-clockwise. Sum of anti-clockwise is equal to sum of clockwise moments. After writing that statement, that condition that you are going to apply it, we shall start with our first anti-clockwise moment is t. So you know our moment is force times distance, the perpendicular distance. So the force is t times the distance we determined was
50
centimeters plus. Do we have any other anti-clockwise?
Yes.
That is the Newton force.
4
times
times 35.
Any other anti-clockwise force?
No.
Wonderful. Then we say equal to. Then sum of the clockwise moment. The only clockwise moment we have is
8 times
6 newtons times distance 40. Okay, then we quickly get to our calculators and get 50t plus
100.
140. 140 is equal to
Teacher, we can't sit down.
320.
320. 320.
we get the 320. Okay, mathematically, when 140 goes the other side, what happens?
You subtract
It
100.
becomes a minus. So which brings us to
50t.
50t equal to
100 is equal to 100.
Is equal to
180.
50t is equal to 180.
50t. 50t
180. 180.
180.
Blackboard is high. You're writing high.
Okay, divide by 50. So
3.6.
what do we get?
3.6.
3.6.
What unit do we put there?
Newtons.
Wonderful. Forces are measured in newtons. Wow, you clap for yourselves. Okay, thank you so much, because that was beautiful. Now I'm going to ask you something. We have ignored a certain force on that meter rule, and it is because of that word uniform. Okay? Uniform meter rule, and where the meter rule has been quoted. So anybody who can tell me what force we have ignored and the reason why we have ignored it?
The first center of gravity. Out of the word center.
What have we ignored?
The center of gravity.
Center of gravity.
The center of gravity acts as the middle, isn't it?
Yes.
And what force is at the center of gravity?
Wait.
So how far is the weight from the pivot?
0.
What is the distance of the weight from the pivot?
0.
Okay, beautiful. So that is why we ignore the moment due to the weight, because what is the reason?
0.
Its distance from the pivot is 0. Because its distance from the pivot is what?
0.
0.
Note of that statement. That's why you ignore that weight, because that weight gives you. I think Mr. Sadi, if I give this statement, gives you the reaction. Okay, may require reaction. Okay, Rosemary Nabatanzi, are you in? Rosemary, you posted something in the chat which says, excuse me, teacher, how come the sum of the upward forces is not equal to the sum of the downward forces as said in the condition? In the previous question, Rosemary, if you're there, you can get in and we. So in the previous question, there's a force which wasn't dealt with. Every time your weight acts downwards, what is that other force that acts upwards when you sit on a surface? From forces, can someone remind us S1 forces? S1 forces, every time you sit on a surface, your weight acts downwards, but there is unequal but opposite something that acts in the opposite direction. Can someone remind us from this one?
Reaction force.
Reaction force. Okay. Now, if in case there was a part B on this question saying determine the reaction at the pivot, because Mr. Senjove is saying that there is a force to ignore the weight of this meter rule at this point, that weight we ignore because we take moments about this point, okay?
Yes, teacher.
But so because of this weight of this meter rule acting at this point, there is an equal but opposite reaction acting in the opposite direction. So there is another force there. And it can be examined where they say determine the reaction at the pivot. So Rosemary, in the previous question, we did look into the reaction, but in case it was a question, our second condition comes into play. Our second question comes into our second condition, which says that the sum of forces acting in one direction is equal to the sum of forces acting in the opposite direction. Okay, can you apply it and get a reaction at the pivot? Okay, let's solve it as part B of the question.
I want us to look at that.
It is put it as part B.
Okay, part B, it says that determine the reaction at the pivot. Determine the reaction. Determine the reaction. Determine the reaction at the pivot. Please say by determine the reaction.
Already.
And
there was a volume in the room.
Determine the reaction at the pivot.
She has a system. It is plus. You don't unless this wasn't if it wasn't negative. No. Pivot will not have yes, but it's at the center.
Okay, so you proceed. Upward forces. Okay, so the condition says some of the forces acting in one direction. You may or may not write this one. Some of forces acting in one direction, is equal to sum of forces. Some forces acting in the opposite direction. Acting in the opposite direction. Acting in the opposite direction.
180
So can you tell us the sum of the forces acting downwards, girls? I hear you becoming is whatever. So add the sum of the forces acting downwards. From your diagram. Can we have some of the forces in one direction?
4 times 4 times 5.
The forces only here, you are now looking at the forces that are acting downward. Okay, let's come to, I believe you have this diagram in your notes already. So which force is acting in one direction and which force is acting in the opposite direction, which you can refer as upward and then downward direction.
4 plus 8 and downward direction.
4 plus 8.
4
plus 8 is a sum
8.
in one direction and then
R plus T.
R plus T, wonderful. So we can now come and do that. So that means we have R plus T is equal to 4 plus
8.
Then when we come to R, what we're looking for, T, we got it as
3.6.
So 4 plus 8 you get
12.
So R is equal to 12. We get R as
8.4.
8.4. It's also a force, so we get it as
Newton.
Newton. We get it in newtons.
Isaac.
So for all questions that we will ask for this reaction, we shall use the first condition for equilibrium. Sum of forces acting in one direction is equal to sum of forces acting in the opposite
direction.
So for most of our cases, we use sum of upward forces is equal to sum of downward forces.
Okay.
Okay?
No, teacher, it's not talking.
Okay, any question? We are time
Yes,
is
teacher.
Excuse me, teacher.
we
The first time explain reaction again.
explain reaction. That's what I've heard. Now listen, girls. I believe most of you are seated on a stool or a table or a chair.
Yes.
So when you sit on something, what force do you exert on that?
Not when I
What is the force you exert on your support or your chair or your stool? What is the name of the force you exert on your?
Weight.
It is your weight. Is that okay?
Yes.
Yes.
Now, suppose somebody pulls the stool away from beneath you. What will happen to you? We play
You
this game
fall.
whereby you want to sit and somebody pulls away the chair. What usually happens?
You fall.
You fall.
You sit down.
You fall. If the support is good, you fall. Now that implies that the chair must be able to support you, and when it supports you, it exerts an equal but opposite force on you in order to support you, so that the two forces balance each other. Your weight and the reaction must balance each other for you to sit comfortably on a chair. Are we getting the point?
Yes.
So for forces to balance each other out, when one force acts in one direction, there must be another force to counteract it that is acting in the opposite direction. And that force is what we refer to as a reaction.
Yes.
And most of those reactions, when it comes to our pivots, they occur at the support, the pivots. That's where the support is, and therefore that's the point where we expect a reaction. So this meter ruler, or this rod here, I want you to look at the diagram, is supported at 2 points. The first point is that one, and the second point is because it is exerting its weight on the pivot. Is that okay?
Yes.
So there is a reaction there, and there is a tension. And these two forces summed up, acting the same direction, they give us the upward forces. Then these forces that all act in the opposite direction must balance with these ones for this body to be in equilibrium. Is that okay?
Yes.
So a reaction force is basically a result of a certain action. So for every action is an equal and opposite reaction. I think we talked briefly about that force, and we said we expound it more as we move to S3. But right now we are saying S2, S3. So we are talking about it. Okay, ladies, take screenshots of this question. You will do it in your free time.
Excuse me, teacher.
Yes.
Teacher, I still don't get when you where you use the condition of upward and downward forces, and for tension, the last lesson, when you asked us to find tension, we use some of upward forces.
I still don't get the fact that we need a screenshot.
But for this one, we've used another the anti-clockwise moment is equal to clockwise moment. How do you know which
Okay.
condition?
Yes, I think the person who was asking that question, in this question, people who are making noise, may we have some silence and respond to the question? In this question, we use the first condition to get T. So we already have the tension. You already have the tension using the second condition, sum of the clockwise moments is equal to sum of the anti-clockwise moments. Then when you want to get a reaction, now we use the first condition. You can use them interchangeably depending on one, which is most suitable. When you have a turning point and you want to take moments, use the first one. Use the second one. Sum of the anti-clockwise moments is equal to the sum of the clockwise moments. So we are going to do more numbers, and you'll see that you'll be able to tell when do I use this. And so, okay, you copy this question very fast or take a screenshot because our time is up. That you try it out in your free time. We shall start from there in our next lesson next week.
Okay,
Thank you, teacher.
Thank you, teacher.
Hey, teacher, nice weekend.
Teacher, have a nice
Teacher.
weekend. Bye.
Bye.
Teacher.
Thank you.
Bye.
Nice
I'm
weekend.